Integration by parts once again. So I've got the integral of t squared e to the t dt. And what I want to be able to find is I need to basically break this thing down. I see two definite functions for sure. I have, well, let's just get into it. U, d, u, and a, I'm sorry, I didn't put a u there, and a v and a dv. Okay. So in this case, I'm going to choose the u to be my t squared and my dv to be e to the t dt. And I think that maybe this is a technique that I'd like to show you, is the reason why I chose the dv to be the e to the t dt is because if I take the derivative of u, then I'll get 2 times t. And I simplify my function, which is a good thing. I want to try to get it more and more simple. And if I take the integral of e to the t, well, that's actually pretty easy. It's just e to the t. That's the nature of taking the integral or even the derivative of e to the t. It kind of hangs out. So what's going to happen is I'm going to end up with functions where this term is going to get simpler and simpler, and the other term is going to stay the same. And hopefully this term will get so simple that I'll know how to take the integral of this. So let me just write down the integration by parts formula once again. Integral of u times v, or I'm sorry, u dv is equal to u times v minus the integral of v du. All right, plugging this straight into our equation, we have t squared e to the t minus e to the t du. Oh, I'm sorry, this would be 2t dt. There we go. 2 times t dt. All right, are we done? Let me see. Let me just simplify this a little bit. By the way, I'm going to drop this down because that's what it's equal to. T squared e to the t dt. You know what, to be honest with you, I don't know how to integrate that. Well, I can pull the 2 out for sure. Minus 2 times the integral of e to the t times t dt. So what I'm going to do is a really kind of a tricky thing. I'm going to actually take the integration by parts again. IBP, integration by parts, again. U and a v, du, and a dv. All right, my new u this time is going to be just regular t, and my dv is going to be e to the t dt. Now, how did I choose that one? Well, there's going to be this trick to kind of simplify this. You're going to want to kind of choose things that obviously they're not the same exact as your u and dv and du and v above, because you have a different function that you're dealing with, but it's of the same kind of style, of the same form. In this case, u, taking the derivative of this, is just dt, and taking the integral of this, it's e to the t. So what I have is, let's plug this straight into the equation again, and remember this is the equation, so I've got t times e to the t minus the integral of v, so that would be e to the t dt. And guess what? Like I said, look, we've simplified this thing so much so that we have something that we know how to take the integral of. The integral of e to the t is just e to the t. I need to plus a constant here, and t e to the t. Now, I need to remember that what I'm doing is I'm trying to find this answer right here. Over here is the integral of this. So I still need my minus 2 out there. And then I still have my, look right here, it says t squared e to the t. So simplifying all of this, let me see, I've got t squared e to the t minus 2 t e to the t minus 2 e to the t plus, well, I guess you can say, actually this would be a plus, wouldn't it? Because that negative got distributed. And then this would be minus 2 times a constant. And actually, you don't really need this 2 times a constant, because this constant can be anything, so we can just absorb that 2 into that constant. We don't necessarily know what it is, so we'll just leave it like that. And there we go. That is your answer, actually. And yeah, there we go. I guess what you would want me to do is do the check, right? And take the derivative of this to make sure that I get my answer back. And I'll tell you what, I'm going to leave that as an exercise up to the student. Make sure that I did that right.